Hi, in this video we're going to machine the 1, 2, 3 block we did in the previous video, but we're going to do the sides as well. This is going to be on a VF4 with 5th axis trunnion. So in case you haven't seen it before, I'm going to show you how I set it up. Start out with a setup right here. And you can see I already have the machine downloaded with the trunnion table and the head right there. When you do this, right click on your setup and edit it. Right here, go to machine select, and you can go to the Fusion library and download whatever machine they have available. I'm more used to a Haas VF4, so we're going to use this one. Press select. I already have mine selected. I edited mine so that the kinematics of A axis is minimum range 0, maximum range 120, so that the 5th axis tilts towards the operator so the operator can see what's going on. It's a pain in the butt for it to flip backwards, even though it's kind of like safety, I guess, but I would rather see what's going on than not. Select the top of the part in your program for the work coordinate system. Select your x-axis, all the stuff we previously did. Part position, I left it at 0. This is a new tab here, part position, when you do a setup and you have a machine in there with a 5th axis. The kicker is you have to know what I call swing is from the center of your 5th axis, A axis, to the top of your part. So you have the trunnion table. You'll probably have a chuck or something, and then the chuck will be holding the part. How do you know what's what? If you set 0, XY 0 from the top here, and then swing your table 90 degrees so that your part's laying down towards you, and you touch off and find what your Y axis is, that becomes the swing number. And I put that in your Z right here. It could be 0 if your part was on the table, like that. No one's doing that. It could be some odd number. If you're using Haas TCPC, it can be, you have to set that number first, then you can use your Z-axis probe, and they'll work together, those two numbers, and you won't have to do all of this stuff every time you do a program. But this is how you set it up. You find that swing, load it in your macros or load it into your program here. I'm going to put 4 inches here just because, for random. The attachment point is going to be in the center line of this table, right there. So I just hit OK. Now our chuck is invisible. We can later on I'll build a chuck and I'll show you how I did that, and we'll add it into this program. I copied a bunch of tools from the previous setup. Facing we already did. Side milling, finish side milling, center drill on the sides, drill on top, drill on the sides again. And what this is just a glorified drilling program, but we could get 5 axis out of it, or 5 sides out of it, instead of just machining one side. This still isn't the best way of doing it. I would probably, this is okay because you want the shortest drill. So we're drilling from the top, and then we're drilling from the side in, so your drills and everything are not sticking out too far. It'll work. So, all right, we did all the tools. And when you have the Haas machine downloaded, you can turn on or turn off the base. And that comes on if you highlight the setup like this. And this is an old computer, so it's actually still rendering it pretty quick. You can see in there your y-axis, your x-axis, z-axis, just like normal, you know. Z, Y, X, all positive. Same thing. What I do, I want to see what's going on, so I'll turn the base off. It just leaves me the table, the trunnion, and the Z. You can still see everything that's going on. So with all our stuff loaded, that's a regular Z tool, regular Z, everything is in 90, normal. This center drill is also normal. But when you go to the next tool, I just duplicated this. When you right click it and edit it, you go to multi-axis, highlight that, then tell it which side you're drilling from. It could be any one of these other 4 sides. Definitely not the one you're holding on to, obviously. Tell it which way is X. Hit OK. I have 2 here. I'll copy this one and make another one. Right click, duplicate. Right click on the new one, edit it. And that highlighted, the blue highlighted surface, that's where it thinks 0 is at. So we're going to change that. We're going to go right here. Then we're going to change the holes we're machining to, let's do 3 of them. 2, 3. And press OK. Now you have the tool ending there. This is simulation for see if your tool's clear, see if your program works. The simulation works better if all of your tools have a tool holder. Sometimes the trunnion will turn and the center drill will be so far into the spindle taper that the head of the Z-axis will hit the trunnion, or it will hit the backside of the trunnion or something. And it becomes an error. So do yourself a favor, when you're making your tools, add the tool holders. If you're going to use an extended tool holder, add it in there. Fusion has a whole bunch of different ones. It's not always perfect, but you get the gist. With that, that's 3 center drills on 3 surfaces. I have 2 drills, so I'm going to add another drill for the 3rd surface. Same thing, right click, edit. Go to multi-axis, turn it on. Select the face you want to machine on. That wasn't the one. That one right there. X-axis is the same. Press OK. Oh. Right click. We got a red triangle because our hold center selection is not correct. So we'll come in here, select the 3, press OK. And the drill's not going deep. This is just for an example. You can change your Z depths however you like. We got all green checks. Press OK. Let's back out a little. See if we can get everything in there. Go to machine simulate. This computer takes long. It's not the latest and greatest. It's just a regular MacBook Pro from about 6 years ago. But you can run the simulation on your computer. Verification complete, no issues found. Press OK, press play. You see our Z coming down. Let's scroll a little bit so we can see what's going on. And here we have the Z, the head stationary, and the part moves around. That was roughing. Finishing the exterior. Machining the top. You see the head tilt. Drill 3 holes. And it turned again. Still at 90. Now we reset for the drill. drill the top, drill the side, 2 holes, turn around, drill 3 holes. Machine goes back home, Y-axis comes to the front for the operator, and you're done. That's the simulation. Now I'm going to back out and show you how you would see it if you were the operator. You would be about right here, and you could see your machine machining the side holes in front of you instead of from the back side, which doesn't make any sense. If it was a pure production, it wouldn't matter, but you typically would want to see what's going on. Now I'm going to show you one more thing to show you why the swing number is very important. Let's exit the simulation. We have a gap here of 4 inches. Our chuck or whatever hork holding situation we have going goes there. Let's say it was taller. Let's say it was 8 inches. Much higher. Reduces our Z machining envelope, but still, let's say that's all we have. Let's take that and we'll simulate it again. And wait for the beach ball. Press play again. Now you see the Z-axis is machining higher. Tool change. Tool change. Now let's watch from the side how far over it goes. Oh, that's almost at the end of the travel of Y-axis, see? You can play with that, whatever your setup you have. Of course, it's better to keep it tight and to the center, but that number is not always optimized. As long as you know it, your program will come out right. How do you fix it? When you run this program and you see your swing for Y, look at that Y number. If it's like Y minus 1 inch or so, you know your program's wrong. Your swing is wrong, or your post is wrong. Play with that number, spit it out. You can see that when you swing all the way across, that number will be offset from Y. That's how you know that that program is working correctly. So that's about it. If you have any questions or comments, leave them in there in the comment section. If this was helpful to you, give me a like and subscribe.